This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.7 on projectile motion. Question number 12, 13, and 14, a three-part problem. It says a ball of mass 0.3 kilograms, we don't care about that, initially at rest, is kicked directly towards a fence from a point 20 meters away, as shown below. The velocity of the ball as it leaves the kicker's foot is 18 meters per second at an angle of 61 degrees above the horizontal. The top of the fence is 9 meters high. The ball hits nothing while in flight and air resistance is negligible. The first question is determine the time it takes for the ball to reach the plane of the fence. Well, I better get started with X world and Y world. Now, I know this ball is going to go 20 meters this way, it's going to fly, and it's going to come towards the fence. Well, 9 meters is the fence, so I'm going to leave that out of here for a moment. So, X world. I know that my acceleration is 0. I know that my displacement in the X world by the time it gets to the plane of the fence is going to be 20 meters. I don't know my time, but my initial velocity in the X world, or my final velocity, or my all-time velocity in the X world, is going to be the X component of this velocity. So this velocity in the X world is going to be, since it's adjacent to that 61-degree angle, it's going to be that velocity times the cosine of theta, because cosine has to do with the adjacent. So my velocity in the X world is going to be 18 cosine 61. I don't know time, but I guess I can get it pretty quickly over here. In the Y world, my acceleration is negative 9.8. I know that I don't know my displacement. I'm going to be wondering about that later because this 9 meters is actually the fence itself, so I don't know about that. My initial velocity, I know, is going to be the Y component of this 18 meters per second. So my initial velocity is going to be that velocity of 18 times the sine of theta because I'm dealing with the opposite side. So my initial velocity in the Y world is going to be 18 sine 61. And that'll give me my initial velocity in the Y world. Determine the time it takes for the ball to reach the plane of the fence. You know, I don't even need Y for that. I can do that all in the X world here because I have a velocity and a displacement. So I know that since my displacement is my velocity times time, that my time is going to be my displacement over my velocity. So my time is going to be my displacement of 20 meters divided by my velocity of 18 cosine 61, and that's going to give me my time. So that is the answer for question number 12. Question number 13 says, how far above the top of the fence will the ball pass? Consider the diameter of the ball to be negligible. So what I'm really looking for is this height here. Now I have no equation to give me this height here, but I do have an equation that would give me this height total, right? That's my total y. How high is it? So if I'm looking for my total height y, just for now, I know that at that time, that's the time it takes the ball to reach the fence. Well, that's going to be the same time as I get over there is going to be the same time over here. So can I figure out with an acceleration, an initial velocity, and the displacement and the time, can I figure out the displacement? Sure I can. Y equals v0t plus 1/2 gt squared. So my y is going to be my initial velocity, which is going to be this, times my time, which I figured out from over here, plus 1/2 of negative 9.8 times that time squared, that same time squared. Now this should give me a big number, but this is going to be negative, so I'm going to subtract all of this from that. So that'll give me my height above, sorry, that'll give me my total y. But the question wasn't asking for the total y, it says how far above the top of the fence. So for me, if that's my total y, I'm going to subtract 9 and get my actual value, how much above the top of the fence. So I think they worked it out where this is going to be a positive number bigger. If this winds out to be 8, you'd have to say -1. If this winds up to be 10, then I'm 1 meter above. If this winds up to be 20, then I'm 11 meters above. So whatever your y is, subtract the height of the fence, and you'll get your answer for part number 13. Now, question 14 says, what is the vertical component of the velocity when the ball reaches the plane of the fence? Well, if I'm talking vertical, that's y world. So now what I want is my final velocity in the y world. Well, do I have an equation for my final velocity? Sure I do. It's my initial velocity plus my acceleration times time. Since I know my time from that first part, this is pretty easy. So my final velocity is my initial velocity, which was my 18 sine 61, plus my negative 9.8 times my time. And the time is this time, which is the time that we're dealing with. So this is negative, this is positive. This will be a negative value, which I'm going to subtract from my initial velocity, and I'll get my final velocity. I don't know if that'll be positive or negative, but we'll see. If negative 9.8 times t is more than v0, then it might be a negative number. So whatever you get here, that's what you're going to plug in here, because it's saying the vertical component of the velocity, so it does matter positive or negative. So whatever you get here, whether it's positive or negative, enter it in as positive or negative.